Hey, how's it going, everyone? Hope you're all doing well. My name is Taha. Welcome back to day 2 on the 30-day LeetCode challenge. Yesterday, I covered question number 1, which was called Detect Capital. If you didn't get a chance, make sure you check that one out. Today, we're covering a question called Design HashSet. So let's see what this question's about. It says design a HashSet without using any built-in hash table libraries. Okay, to be specific, we should be able to include these 3 functions. We need to be able to add a value to our HashSet, see if a value is contained in our HashSet, and remove a value from our HashSet. Now, before we go and look at the example, just to get an idea of what it does, let's actually just review what a HashSet actually is. Because when I was doing this question for the first time, I kind of forgot what a HashSet was and how it works exactly. So let's just quickly go over that. So basically, a HashSet is a collection of unordered, unique items that stores values based on a calculated hash. Now, let me break that down a little bit for you guys. It's important to remember that a HashSet is unordered. Okay, unlike an array, you don't have to necessarily start from the beginning of the hash set and find items by indexing forward. Items are unique. So just like a mathematical set, a hash set cannot contain duplicate items. Okay, and the items are stored based on what's called a hash. Now you may be wondering what a hash is. Simply put, a hash is just a number that represents an index in the array that we're going to be storing our value. Now, this is what makes a hash set much more efficient than an array in general, because we don't need to access each item in the array potentially to access an element that we're looking for. All we have to do is go to the hash of that value and we right away have it. So instead of being linear time, we actually have constant time for removing and checking if an item is contained in the list. Now, another question is, how do we calculate the hash? Okay. Basically, we use what's called a hash function. Now, a hash function, I'll call it HF, takes in some sort of value and it returns a number. Now, that number is going to represent where in the array that we're going to be storing our value. Now, there's different ways that you can calculate this value from the hash function. Just to keep this a little bit simple, I'm going to basically be using the modulus operator to calculate where I'm going to be storing my value. So I'm going to take the value that was given and I'm going to do the modulus operator with the length of the array. So basically, this will always guarantee that we have an index number that's going to be within our array. So for example, let's say we're trying to insert the number 10 into our hash set. Okay, our hash set has 5 locations for now. They can obviously have a lot more, but for this example, we're just going to go with 5, just to get the point across. So number 10, in order to input that into our hash set, we're going to use our hash function to calculate the index position. So it's going to take in 10 and it's going to go 10 mod, in our case, 5. And if you don't remember what the modulus operator does, it basically just returns the remainder after division. So in this case, it's going to be 0 because 10 divided by 5 is 2 and there's no remainder. So 0 would be the index position that we store number 10. So number 10 will be stored in this position. Let's say we're trying to store the number 11. If we're trying to store 11, we pass 11 to our hash function, let it calculate what index number we should insert it at. In this case, it's going to be 1 because there's 1 remainder, and we're going to insert 11 in this position. Now, a question that comes up is, what if we have 2 hash values that end up being the same? And this is called a collision. So let's say we're trying to insert the number 15. If we try to do 15 mod 5, we're also going to get 0, which means that we have a collision because there's already an item in the 0th index. So to solve this, we actually create another list within the index number 0 that we store the rest of the items. So in this case, we'll add 15 into the same spot as 10, but now 15 and 10 are going to be stored in their own list. So there's going to be a nested list within index number 0. So this is the idea here. Now, because of the fact that we use a hash to keep track of where we store our values, it makes it really easy to remove and check if an item is contained in the list. All we have to do is take the number that we're given, compute the hash of it, and then go to that section of the array. And if it's there, then we can return true if it's contained. And if we want to remove it, then we can go through the array that's at that location and remove the necessary value. So let's go ahead into the code and see what this looks like implemented in Python. All right, so I've taken the default code that the question already gives us. So let's start with the init function. Like I said, the way that we'll be implementing a hash set is through an array. So first we'll start with setting the size of our array. And for now, I'm just going to choose an arbitrary size of 64. And we're going to initialize our array with 64 null values. Self.hashmap equals an array of none times self.size. All right, so this will ensure that we start off with an array of 64 items that don't have anything in them. Okay, so let's implement the add function. So remember, when you're adding an item to a hash set, the first thing that you need to do is calculate the hash. Let's call it key hash, and this is going to be equal to a function that we're going to be writing, which is going to be called get hash for a certain key. Okay, so let's write that function. We're going to take in self because we're referencing the class. So like I mentioned, the hash function is going to take in the key and return the index number. So we're going to call it key hash equals, we're going to take the key and we're going to do mod self.size. So this is going to make sure that we get a number that's between 0 and the length of our array. And we're going to return key hash. So far in our add method, we have the hash of where we're going to be storing our item. Okay, so now that we have our index, we're going to say if self.hashmap at key hash is none. So if we have nothing stored at this location at the moment, then we're going to store at this location the key that we were given. And remember, we're going to store it as a list. So in the future, if we have a collision and we want to add another item onto the same index, we can just append it onto this array. What if there's an item that's already there? What we want to do here is make sure that we don't have duplicates added in our array, right? So we're going to loop through each item in self.hashmap at key hash. And as we're looping through it, we're going to say if the item is equal to the key that we're trying to add, then let's just print out, for example, for now, already in key, already in list. And we're just going to return. But if we go through the entire array and we haven't already added this item here, then we're going to say self.hashmap at key hash dot append key. So let's just quickly review what we did here. To add an item to our hash map, we basically calculate the hash of the key that we were given by using this function called get hash. Get hash takes the modulus of our key and the size of our array, and that gives us a number that's between 0 and the length of our array. Once we have that index number, we check if the value in our hash map at that location is none or not. If it is none, then we're going to add an array that contains our key to that location in the hash map. Okay, if there's already something at this location, meaning there's a collision, then we're going to go through every item in the array that's already in that section of the hash map. And if that item is already existing in the hash map at that location, then we're just going to return. Otherwise, if we haven't found that item, then we're just going to append it to the end of the list. All right, so now that we've implemented the add method, the remove and contains method should be more straightforward since we have a better understanding of how to get the hash and we already handle collisions and duplicates in the add method. So the first thing that we want to do is, again, take the hash of the key that we're given. What we're going to do is take that hash, see if there's anything in the hash map at that location, and if there is, then we're just going to remove it from the array. So first of all, we're going to say if self.hashmap at key hash is none. So let's say we're trying to remove an element or a key that actually doesn't exist in the hash map yet, then we want to just return. But if there is an array at that location of the hash map, then we want to see if our key exists in that location. if key is in self.hashMap at key hash. So if we did find the key in the array of the hash map, then we want to say self.hashMap at key hash dot remove. And what do we want to remove? We want to remove the key. And then we're just going to return. But if this if condition was never met, so we never did find the key that we're looking for, then we're just going to return. So going off of the example that we talked about earlier, let's say we're trying to remove the key of 15, right? It's going to calculate the hash of 15, which in the case of this example would be 0. It's going to go to that 0th index. It's going to see if 15 exists in the array, in this array, and if it does, then we're just going to remove the 15. All right, so given that we've covered the add and remove methods, the contains should be the most straightforward. So the idea is we're going to take the hash that's calculated for this key, and we're going to see if there's an array at that location of the hash map. If there is, then we're going to see if our key is in that array, and we're going to return true or false if it's not. So first of all, if self.hashMap at key hash, this is sounding repetitive, I know, bear with me, is not none, so we have an array at that location, and key in self.hashMap at key hash, then we're going to return true. So this basically just says if I have an array at this location of the hash map and the key that I'm looking for is in that array, then I'm going to return true. If that's not the case, then let's return false. I just realized there's two mistakes. First of all, there should be is not none. And second of all, for all of these get hashes that I've been calling, since this is a class, I need to be saying self dot. Okay, that should be good. Let's test this out. So I've copied over the basic test case that was given in the question. So let's run these tests and see what happens. So for the first one, we add 1, we add 2, and then we check, does it contain 1? And in our case, that's true. Then we check if it contains 3. In this case, that's false. Then we add 2 to it. And what our code printed was key already in list, which tells us that we do handle collisions properly, and we handle duplicates as well. So we check if it contains 2, which returns true because there's already 1, 2 that we added from before. We remove that 1, 2, and then we check again if it contains the 2, which is false. I could run some more tests and show you guys some more examples, but at the time of making this video, it's already 11 o'clock and I have work tomorrow, so let's submit it and see what happens. Okay, it's been accepted. Let's see the runtime and space complexity. Okay, so we beat 62% for runtime, which is all right. I'll take it for now. And 57% for memory. Okay, not the best. I can probably improve memory. If you guys have any suggestions on how I can improve it, let me know. I'm just trying to get the habit of sit down and actually doing these questions every single day and making a video to post for you guys. So that's going to be the end of this one. If you guys found this one useful, you learned anything new, or you enjoyed the process of it, feel free to like and subscribe, and I'll see you in the next one. Thanks.